Sports science energy systems. There are many energy systems needed in your body, and one is called the adenosine triphosphate system, also known as ATP system. This is an anaerobic system where it doesn't need oxygen and is stored in the muscle cells. This system releases energy by having one adenosine and three phosphates. Connecting these are high energy bonds which are stores of energy. A bond gets broken by enzymes. Which are called the ATPase enzymes. This causes a phosphate to disconnect from the ATP and become ADP, as there are only two phosphates instead of three now. Therefore, when this bond is broken, energy gets released and heads towards the sliding filament theory that I said in another video. And this is where the myosin and actin in the sarcomere of the muscle will slide along each other, causing contraction where energy is needed. ATP can only last for around 3 seconds, so it needs to be resynthesized. This is where phosphocreatine, also known as PC, which are also found in the muscle cells, where it gives a phosphate ADP to form ATP again. Then a cycle will be shown. ATP lasts for around 3 seconds, therefore it will be used in sports such as high intensity, such as 100-meter sprint. This is a low duration where other systems such as aerobic system will be needed for long durations such as a marathon. Therefore ATP is benefit for short distance exercise, however useless for long. For the ATP to resynthesize, there has to be PC present, as PC delivers a phosphate molecule to ADP to form ATP. PC contains phosphate and a creatine. They are found in the muscle cells as well. When the phosphate gets released from the PC, the only molecule left is a creatine. This high energy bond between the phosphate and the creatine is broken by enzymes called the creatine kinase. When the phosphate gets released from the PC, the only molecule left is a creatine. The energy that gets released from the breakage of the bond goes towards the ADP, where it will build up so a high energy bond can be present when the phosphate returns to the ATP. This system is very simple, however it is essential for ATP and our muscles. The duration of this only lasts around 7 seconds, so there is once again a low duration but high intensity. As a result, the energy system becomes ATP-PC, where altogether it will last 10 seconds, and so a 100-meter sprint would use both ATP and PC. Another energy system used is the glycolytic system. This can also be named the lactic acid system. It is also an anaerobic system and lasts around 2 to 3 minutes. The word glycolytic means the splitting of glycogen or glucose into energy. The system works by glycogen breaking down the glucose into glucose by enzymes called the glycogen phosphorylase. The glucose then breaks down into pyruvic acid through the enzyme phosphofructokinase. When the glucose breaks down, it will release energy enough to resynthesize 2 ATP molecules to carry on this system. Oxygen is needed for further, and this system is anaerobic. Therefore, the pyruvic acid will just break into lactic acid through the enzyme lactate dehydrogenase, where this will cause a decrease in pH, meaning an increase in acidity. Unlike pyruvic acid, lactic acid is a strong acid that can cause discomfort to people such as fatigue. That is why the more you exercise without oxygen, the more you would need energy for your muscles, meaning the glycolytic system will be used more, which creates lactic acid. This system is very good for around 2 to 3 minutes at maximum intensity, or submaximum intensity, or any intensity. Our class measured the blood lactate of 2 students in 2 different tests. The first student did the multi-stage test, which is like the bleep test, and the other test was the Wingate test, cycling on the spinning bike maximally for 20 seconds. Everyone's blood lactate is around 1.6 millimoles per litre, so at rest both tests will start with 1.6. In the multi-stage test, the blood lactate increases dramatically from rest to level 4 because when the glycolytic system is used after 10 seconds, it produces a lot of lactic acid which lasts around 2 to 3 minutes. Therefore, the more amount of glycolytic system is used, then the more lactic acid is produced, causing the blood lactate to increase all the way to the post-test. The end result is around 19 millimoles per litre, which is quite high because the glycolytic will be getting used much more frequently to produce more energy than before to try and keep the student in high energy. This shows that the more fit you are, the less acid will be produced. This is very similar to the Wingate test, as the lactate also rises high at the post-test at around 21 millimoles per litre. The glycolytic system may only last around 10. The ATP-PC system may only last around 10 seconds, but it is at maximum, therefore it is resynthesizing the ATP as quick as possible to provide the most energy. Lactic acid is a waste product, meaning the body will need to get rid of it, and that's what the blood does when it takes the waste product out of the body when it goes through diffusion into the atmosphere. Meaning after a while at rest, the lactic acid will reduce back to around 1.6, and it will still get produced through small movements, but nowhere near as much as compared to when exercising. In the sports football, many movements will need energy systems. Different movements require different energy systems due to the intensity and duration. For example, in a sprint, when dribbling with the ball in football, you will be at maximum intensity, but it can vary how long you are running. If you are running down the wing with the ball, you'll be running for around 10 seconds, meaning you'll be using the ATP-PC system. This is because the ATP-PC lasts around 10 seconds, as the phosphocreatine is the immediate system that resynthesizes the ATP. The glycolytic system may be used if the run lasts more than 10 seconds, when perhaps running down the wing for a longer distance or starting a counter-attack. It all really depends on the intensity and duration to determine which energy system will be used. Over the course of 90 minutes, the aerobic system will be needed the most, as you will need oxygen so you won't fatigue quickly. Goalkeepers will 99% always be using the ATP-PC system, as their job doesn't usually last more than 10 seconds. When exercising, your first system will always be the ATP-PC system, followed by the glycolytic system, leading to the aerobic system after 2 to 3 minutes, where exercise will start to become a bit less forceful, as you'll be able to run easier with the aerobic system as the muscles are getting the oxygen they need.